guys, here we are again with another lesson focusing on area here. You've been working with possibly finding the area of triangles, and you may have had a situation that you could not use our beloved 1/2 times length times width, or that you couldn't use the sine rule for area. So we have a new formula that we could possibly use to solve the issue. Heron's formula for area. It reads, area equals the semi-perimeter, yes I said semi-perimeter, I'll explain what that means, S multiplied by S subtract A multiplied by S subtract B multiplied by S subtract C. And evaluating that will give us the area of the triangle. Now, in this, a couple of things to talk about, obviously, is A, B, and C. They are all sides of triangle ABC. So they are the side lengths of your triangle. And S represents, quotations, and S represents the semi-perimeter. And it is a high chance that this is a new word for you, semi-perimeter. How we evaluate this, how do we find this semi-perimeter? We take the three side lengths and combine them, okay? And we divide that value by 2. So one way to remember this, perimeter means you find the total of the side lengths. Semi, as in like semicircle, semi we can also think of half. Think half perimeter. So this Heron's formula utilizes the half perimeter, or the semi-perimeter, and the three side lengths. So you are possibly thinking, what kind of triangles can I use this with? Well, we would say the needed configuration is side, side, side. Okay, which is really interesting because everything up to this point, we've either needed to have a right triangle or we've needed to have an angle measured. Here, you just need side lengths, which is very intriguing. So let's take an example to begin with. Okay, so example 1. Let's imagine we have this triangle. It has side lengths 8 inches, 7 inches, and 13 inches. And you wish to find the area of it. So structuring this for you, seeing this for the first time, let's find the semi-perimeter first, where we combine the side lengths. We take that value and divide it by 2. So the sum of the three side lengths, that would be 28, and half of that is 14. So our value for S in the formula is 14. And what A, B, and C equals, it really doesn't matter, it's just the three side lengths. So we have our value for S, so now we can take everything and plug it in. So it would have our problem look like S multiplied by S subtract a side length multiplied by S subtract a side length multiplied by S subtract a side length. So we evaluate this and we get, let's see, 14, 7, 6, and 1. My goodness, it's just getting easier and easier. And then when we evaluate the product of those four numbers, we get 588, which is approximately 24.2487, and that's inches squared. That's it. We're done. That's the area of this triangle. So it does require one initial step to find the semi-perimeter, but that is it, guys. This is an incredibly easy formula to use if we have the configuration side, side, side. So I'm going to leave you with this example to try. So let's imagine for a moment that we have length A to be 5, length B to be 12, and length C to be 13. Okay, so we don't even need a triangle for this type of formula. So semi-perimeter. Take a moment now to find that, and to continue on and find the area. Okay, so how'd you do? You found the semi-perimeter, which ended up being 15. Is it possible to have a 0.5 here, since you're dividing something by 2? Obviously, I mean, we're not always going to have an even perimeter, which would make dividing by 2 easy. You could have a 0.5 here, okay? That's possible. Now you get over to the area, the actual formula itself, where you have 15 and 15 subtract in length, 15 subtract the length, 15 subtract the length. Do you always subtract the lengths? Like, could it ever turn to addition? Well, you're saying, if you're asking that question, could these ever be negative side lengths? And the answer to that question is no. So that yes, it will always be subtraction. And evaluating that down, we get 900, which I noticed my symbol here is not approximate because the square root of 900 is exactly 30 units. And also, if you knew this, 5, 12, 13, that's a Pythagorean triple. So this is a right triangle. And 1/2 times 5 times 12 is 30. So if you knew that or not, I wasn't sure. So good luck here. There's not much really I can add to it. It's just finding the semi-perimeter, using your formula, and working through the steps. And that's it. So good luck, guys, practicing this and applying this further in application problems. See you in the next video.